In this example, we are going to be talking about the infamous ladder sliding down the wall kind of a problem. So it says the ladder is 10 meters long, pretty big ladder, is leaning against a vertical wall with its other end on the ground. It says the top end of the ladder is sliding down the wall. When the top end is 6 meters from the ground and it is sliding down at 2 meters per second. How fast is the bottom moving away from the wall at this instant? So this is a related rates, and we are going to need to set up our equation, draw ourselves a picture, and let's see if we can make some sense out of things. Okay, so we have a wall, a distance, and a ladder. All right, so anytime that I draw any kind of a right triangle, I'm going to instantly want to label my x, y's, and I'll put the hypotenuse as a z, right? So let's figure out what we got going on. It says we have a ladder that's 10 meters long. So that z is 10 meters. So I'm going to start to organize, which I think is a huge piece of all of this, is let's organize our given. We know that our z value equals 10 meters. All right, so it says leaning against a wall and it's sliding down the thing. So our y value is going this direction because it's sliding down. Our x value is being kicked out, right? So this thing is sliding out and it's kind of moving along. So this rate is going to be potentially different than this rate. It's all going to kind of be constantly changing as it goes down. So it says the top end of the ladder is sliding down the wall. Here's us sliding down, and then we're sliding out. It says, now here's where they give you a specific. So we're going to find a certain value. So this is the only true given that isn't really changing. When they shift into this of here's your situation, then we're going to be finding a certain value at a particular instance, right? So when the top end is 6 meters from the ground. So now I'm going to draw my very specific triangle that I know that I have, my ladder is not ever changing. My distance on my y is going to be 6, right? And then, so we're going to be using it 6 meters. It is sliding down at a rate. So our y value, our dy, dx, right? We're looking for probably a dx, dt. I messed that up. I'll fix that in a second. dz, dt. So these are all going to be the change of these values with respect to time. So let me tweak my y with respect to time, right? So they tell us that the top end, when the top end is 6 meters, so when this is 6 meters, the rate at which it's sliding is 2 meters per second. Okay. And then it says how fast is the bottom moving away from the wall at this instant. So our bottom is how, so we're trying to find the change in your x's with respect to time, which is the rate, horizontal rate. So that's us moving away from the wall when our y value specifically equals 6 meters, right? And our change in our x with respect to time is going to be, Did say it wrong. dy dt is going to be changing at 2. Now there's a direction associated to this, so I'm going to tack a negative onto it. So it's a negative 2 meters per second. Right, and the reason I'm throwing a negative on is this distance is shrinking. This distance should be positive because it's expanding. So if I have a shrinking distance, that means my rate is going to be negative, right? So it just kind of depends if we're growing or shrinking. So, all right, so we have a y value of 6, and the rate at which the y value is changing is negative 2 meters per second. So what I need is an equation. And I have a right triangle, which screams Pythagorean theorem. So x squared plus y squared is going to equal z squared. What I need to do before I do any plugging in or any subbing out with all these values that we know is we need to find the rates with respect to time, which means we need to do the derivative with respect to time. So if I do x squared, I do the derivative, it's going to be 2x times dx dt because I'm doing the derivative with respect to time, plus 2y dt equals to z dz dt. All right, so what I'm constantly trying to figure out is all this given information, what do I have and what am I looking for? I'm looking for dx dt. That's the one that I'm looking for. So I don't know this value right here, right? But I should know every single thing else. So at a very particular moment, our y value is 6, right? They're talking about when it's at 6 meters from the ground. Our ladder is 10. And if I know my Pythagorean theorem or my Pythagorean triples from geometry, this is a 3, 4, 5. That's a multiple of a 3, 4, 5. So it's going to be a 6, 8, 10. So I have 2 times 8. And then I'm looking for my dx dt because we're trying to figure out how fast it's horizontally slipping out. I don't know that value. My y value is 6. My rate at which the y value is changing is -2. Our z value is the length of that at that particular time. Well, it's 10 because it's actually the ladder, and it's not changing at all, which is going to be an important part, because that is our rate at which this is changing. A rate at which the hypotenuse is changing, it's not. It's staying at 10, which means our rate is not changing. So dz dt. So this gives us a 16 dx dt, and then this multiplies out to a -24. This is 0. We'll add our 24, divide by our 16. So that's going to equal 24. Divide by 16, divide by 16. And that gives us a rate, a horizontal rate. And notice how that negative was getting smaller. So when I bump it over, I get a positive rate, as I should, because that distance is increasing, right? So we should have a positive rate of whatever 24 divided by 16. If I throw that in the calculator, I'm going to get a 1.5, and it's meters per second. Okay, so I should get a positive answer. And even if I got a negative answer, the question is how fast. And so fast does not care about direction. So no matter what, I would have given a positive answer. But my math agrees with it. That's what I want to make sure that's happening. If I would have gotten a negative on this answer, then something wouldn't have felt right. And that's because I would not have taken into consideration that the y values were shrinking. So I should have a negative rate on that. So if I don't account for that, then I get an answer that doesn't seem to make sense. So make sure that when you're shrinking a value versus expanding a value, that those rates should have positives and negatives appropriately, accordingly. All right, so that was the infamous ladder sliding down the wall type of related rate problem.